Okay, so I already wrote all of this out because I forgot to record, as you know. But let's reiterate that we wrote congruent statements for the pairs of corresponding angles in each figure. So number one, we took a look at angle 1. We said it was congruent to angle 5. They're both on the top spot. And then we said angle 2 is congruent to angle 6. They're both in the right spot. Angle 3 is congruent to angle 7. They're both in the bottom spots. And angle 4 is congruent to angle 8. They're both in the left spot. So when they are in the same spot, they are corresponding angles, because corresponding kind of means they're in the same spot. With that being said, let's get on to do the next one, number 2, together. Okay, so let's start with measure of angle 1. I'll write it over here. Angle 1 is congruent to, shout it out, which one is corresponding? Good, I hear you guys say 5. Angle 5.
5.
Good, good, good. Okay. They're both in the kind of like top left spot. For the next one, I'm going to call on somebody, okay? So I'm going to call on a specific person. So we have angle 2 is congruent to, and I want Noah to answer for this one. Which one is corresponding to angle 2, Noah? You have to unmute yourself, by the way.
Ask that again.
Which one is corresponding to angle 2?
I don't know.
So the corresponding angle has got to be in the same spot. So 1 and 5 are both in the top left of their, angle sets. And so you have to choose between 5, 6, 7, 8. Which one looks like it's in the same spot as angle 2?
Six?
Yeah, 6. Good. So 6 and 2 are corresponding angles. Good job. And so they are congruent. I'm going to ask you another one. Okay, Noah? So angle 3 is congruent to, what is the corresponding angle to angle 3, Noah?
7.
Good. See, you got this. Okay, and then let me call on another person for the last one. Let me write it out first. Then we got measure of angle 4. I'm just writing angle 4 is congruent to, let's see, Alex. I want Alex to answer this one. Which one is corresponding to angle 4, Alex? Alex Sordo, are you there? No? Okay. Then everybody, which one's corresponding to angle 4? Because I don't want the recording to go too long.
8.
8's good. 8. Angle 8. Okay. Sorry, that's a really ugly 8. But I hope you guys wrote these down because we're going to scroll on to some more problems. We're not going to do all of these just because time. Okay, so let me take a look at which problems I want us to skip on to. Okay, we're going to skip on to little part B. So we're going to go to the next page. I'm going to clear up all the drawings. Does anybody still need the drawings?
Hey, can you wait for a few seconds?
Okay, yes. Let me know when you're done.
Okay, I'm done. Thank you.
Okay. Anybody else need it? Speak now or forever hold your peace. Just kidding. You can still interrupt me, but please tell me now. 3, 2, 1. Okay, nobody said anything. I'm going to clear all the drawings. Okay, that kind of hurts when I clear it, but it's fine. Now we're going on to the second page. So I want you to go to the second page, and then we're going to make conjectures to explain why each statement is true. So over here, I'm going to start annotating again. I'll just annotate in red because it's easiest to see. Okay, so we have measure of angle 3 is congruent to measure of angle 6. And so in order to answer this, we need to state which theorem we're talking about. And so really we're going to say, is it same side or is it alternate? Is it interior or is it exterior? Stuff like that, okay? So I'm going to call on somebody for this one. Let's call on, let me check through the list of people. Connor, can you tell me, is this 3 and 6, are they on the same side or are they alternate? Connor. You have to unmute yourself, by the way. Okay, so maybe you're not there or maybe you can't hear. I'm not sure because, you know, everyone's got some internet issues sometimes. All right, let's have, I don't want to call on that person because you weren't here yet. Let's call on Jesse. Jesse, can you tell me if these are the same side or are they alternate side? Okay, it sounds like we're having.
Mic's not working.
Oh, okay, thank you. Sorry, I'm like, I can only look at the chat sometimes. Oh yeah, no, you're typing it in. That's good. Alternate side, good. Alternate. Okay, and then let's just have all of you guys shout out if you can, if you have a working mic. Is this interior or exterior?
Exterior.
Exterior.
Okay, so I heard 2 exteriors and 2 interiors. So let me clarify for you guys. When you're deciding if it's interior or exterior, you look at your parallel lines. Are they in between or are they outside of my parallel lines?
They're inside.
They're inside.
In between.
Yes. Like if I just made a rectangle out of my parallel lines, they're like inside my rectangle. They're in between, so these are interior angles. Actually, I'll just keep that there. Interior. So they're alternate interior, and then you just call it a theorem. So alternate interior angle theorem. I'll write that in black, neutral color. Okay, so angle 3 is congruent to angle 6 because of the alternate interior angle theorem. And I saw somebody typed in the chat. Was it privately to me? Let me see. Oh, okay. It turns out a bunch of people have bad internet today, so I apologize if I call on you and you just like don't answer because of your internet. So, sorry. I don't mean to like call on people to make you feel on the spot. I just like want to make sure people are paying attention, but it's not your fault if your internet sucks. Okay, so for number 2, we have measure of angle 1 plus measure of angle 4 equals 180. In other words, they are supplementary. So we're going to see, are they interior or, sorry, are they same side or alternate? You guys tell me, same side or alternate?
Alternate.
So when you're determining that, you take a look at this transversal, the transversal line. Are they on the same side of it? Are they both on the left? Or are they on one on the left, one on the right?
They're both on the same side.
They're on the same side, yes. They're both to the left of this red bold line. Now let's think about, is it interior or exterior? So here's my 2 parallel lines. Good, they're on the exterior of it. And then you finish it up by saying angle theorem. Messy handwriting, but it's fine. So those two angles are supplementary. Do you guys have any questions on those?
Can you explain why it's angle theorem again?
Oh, okay, so here, let me show you. Oof, okay, I'm gonna have to like open a new tab. I know you'll still see the you'll still see the annotations. I'm sorry. Just give me a moment. I'll show you why. Because if you look at our notes, and you go to this red section, it's same side interior angle theorem, same side exterior angle theorem, perpendicular transversal. I guess that one doesn't have the word angle theorem, but look, angle theorem, angle theorem. The only one that's a postulate is corresponding angles. So they all end with angle theorem. That's why I wrote angle theorem.
All right.
Okay. It's a little hard to have side-by-side notes, which is why I didn't put the notes on the side of the sign. Because if the notes are on the side, then the work is so tiny. Sorry. Okay, so does anybody still need to copy these two before I clear the screen and scroll on? Okay, so I'm gonna clear the screen, clear the annotations. Okay, and then let's scroll on to do a few more of these. Okay, so let's do 3 and 4. All right, so we're talking about 1 being congruent to 5. So measure of angle 1 is the same as measure of angle 5. Angle 1 is congruent to angle 5. So let's think, are they on the same side or alternate side of this transversal?
Alternate side.
Alternate, good. I'm gonna call on somebody for the next one, and I hope you're there and have good internet. Wait, did I already call on this person? No, I already did. Never mind. Just you guys answer it then. Is this interior or exterior? Take a look at, are they on the interior or exterior?
Exterior.
Exterior. Good. And then you ended up with angle theorem. Because that's what these theorems are called. They're the alternate exterior, alternate interior, all of that. They all end with angle theorem. Okay, any questions on that one? Okay. Let's see, what time is it? I think that's fine. Okay, so this one, I'm gonna go over it with you again. This is a little bit different. So these are what we call vertical angles. So they're actually not what we covered today, but we covered it last time. Let me remind you by going over to our tab for the notes. Oh, sorry, you have to see that. Okay, so look over at box number 17. You can see the vertical angle theorem. Vertical angles are congruent. So I'm just giving you the answer to this one because we didn't cover it today. We covered it 2 days ago because that's our last class, which is kind of a while for you to remember. But vertical angles is like you can make a bow tie out of it. They're on the opposite sides, and those are congruent. So 1 and 2 are congruent in this box example in our notes. And so when you look over here at 4 and 6, notice I even drew the little bow tie, right? Like, oops, oh my gosh. Okay, right, I'm not annotating. Okay, go back to annotation. Like literally this is a bow tie. So this is what I mean by bow tie. They're on the opposite sides, and if you can visualize them making a bow tie, then these are making up vertical angles. So this one is just vertical. Sorry, this is vertical angle theorem. And I'll show you this page again, but let me just remind you once again, that is on box number 17 right over here where it says vertical angle theorem. Okay, vertical angles are congruent. So, does anybody have a question on that? Okay, so does anybody still need to copy this? Speak now or forever hold your peace. Oh, okay, wait, somebody says they need to copy it still. Wait, was that sent recently? Okay, just type okay when you're done to that person who said me on the chat. Also, sorry, I wasn't looking at the chat for a while, so somebody asked about question 4, now you know. Now you know. So to the one person, okay, you're good. Let's go. So I'm gonna clear all my annotations, which kind of hurts me in my heart, but it's okay. Clear all drawings. Now let's scroll to 5 and 6. And go back to annotations. Okay, so measure of angle 4, that's over here. So let's measure of angle 5, that's over here. They are equaling 180 when you add them together. So they're supplementary. And so let's decide, are they same side or are they alternate?
Same side.
Same side. They're both on the left of that red line. Good. Same side. Good. Now let's do over here. Are they interior or exterior?
Interior.
Good. Thank you, you guys. And then we just end with angle theorem. Angle theorem. Okay. Let's see, we still got a half hour. Okay. Let me double check on the last page, or like what else we have here. Because I think you guys got the hang of it. I think you guys are doing really well. Okay, we don't need to do more types of this type of problem. That's totally fine. If you went ahead, perfect, you got more practice. Does anybody need to see number 5 before I clear the picture? Okay, no one typed in the chat, no one said anything out loud. I'm clearing the picture. Clear all drawings. Let's go to the last page over here. We're gonna skip 7 and 8 because it's the same type of problem that we were just doing. So let's draw and label a diagram to illustrate each theorem. So for these, it's a little bit different. You have to actually draw the 2 parallel lines and the 1 transversal yourself. So that's what we're gonna do. So you can just draw any 2 parallel lines and 1 transversal. I'm just gonna draw it like I'm just gonna draw it like that, whatever. You can draw yours in a slightly different way. You can be creative, it doesn't matter. Like you can copy mine, it's okay. Okay, so same side interior angles. So here's my transversal. Do you guys want me to choose the left side or the right side?
You can choose the left.
Okay, so I'm gonna choose the left side, so I'm gonna draw my angles on this side. And they have to be interior. So they have to be between my parallel lines. So right over here. So they are on the same side. So that means I had to choose either left or right. So we chose left. And then they're interior, so I didn't have an option there. I just have to draw them on the inside of our parallel lines. finally, we must label, well, no, I mean, that's kind of it. That's good enough. That's it. And notice that when I drew my angles, I put 2 arcs on this one because this one has 1 arc already and they are different sizes. So they must have different amounts of like arcs because they're different sizes. So that's how you draw them to show that they are different in size. Okay, let's draw alternate exterior angle theorem. Oops.
Miss J,
Yeah.
when you're drawing angles, do you have to like do one with 1 line and then another with 2 lines?
Well, if they're like the same size, then you can do them both in the 1 line, but only if they're the same size.
Okay. So the only time you need to draw 1 with 2 is if they're like bigger.
Sorry, you broke out for the last part. I couldn't hear. This only time you would need to draw one with 1 and the other with 2 is when,
Like bigger than the other?
yeah, when one's bigger than the other. Yeah, so they're different
Okay.
sizes. Okay, so this one says alternate, so I don't really have a choice. One has to be left, one has to be right, and now they're exterior. So that means they have to be on the outside of our parallel lines. Let me just highlight our parallel lines here. These are the parallel lines. I must choose them on the outside of that. So I'm just going to do one left here and one right here. And this time, notice that they both have just one curvy line to illustrate it, because these are the same measure. They are congruent angles. So since they are congruent, I can illustrate them both having one curvy line, one arc to represent that. Okay, so I have 3 questions that I see. Can we do number 6? Was number 6 in like the last section? Like I just totally ignored you, didn't I? Okay, I'll type you the answer for number 6. It's 5 and 8. Alternate interior. Okay, and then for how are you able to draw on it? I'm drawing on Zoom, so I'm not actually drawing on the document, which is why I really hope you guys can just write on your book, like the physical book that you have, that you got from the school, because that's going to be a lot easier for you than drawing on here. As far as drawing on it, let's see, you could insert shape, no, insert line. You can insert lines, and then you can insert scribbles to draw on it. Like the scribbles can be you drawing these like little red parts, the angles, and then, you know, inserting lines to draw your lines. So that's how you can draw on it. Oh yeah. Oh, good job. Okay, I'm sorry I like took so long to like respond to that. I was looking more at my computer than my iPad. And then the last question that I saw is, do your lines have to have arrows on them? They should, but it's fine if you don't draw arrows. Oops. Let me go back to annotating. Yeah, so right now, since I don't have arrows on mine, technically mine are line segments, but they're still parallel and there's still a transversal there. So the theorems remain the same, even if my lines don't have arrows on them. But I guess if we want to be perfect, we should draw arrows on them. There we go. Good question. Okay. Let's see, how much time we have left? I think we're okay-ish. All right, so usually we don't have enough time for Delta Math in class, but since we didn't do all the problems on this, and it's totally okay, you don't have to finish more. If you want to, you can, but you can turn it in as is. Just take pictures, upload it, and press turn in to Google Classroom for whatever you have. And I wanted to give us some time to work on Delta Math in class because I know Delta Math is a section that a lot of people struggle on. So I think having time to do that in class might help you guys out. So maybe I'll ask for feedback later on and you can tell me, I don't like doing Delta Math in class, I like it at home. Then we'll do that. Or if you like doing it in class, then we'll do that too. Okay, so let me